Video number 4, report number 9, colligative properties. What is a colligative property? Colligative properties are properties of solutions that depend on the ratio of the number of the solute particles to the number of solvent molecules in a solution, and not on the nature of the chemical species present. The first experiment was about increasing the boiling point. First, we did some modality calculations, knowing that the Van Hoff coefficient experimental for the sodium chloride is 1.8. Then after that, we measured the boiling point of simple water, that it was 92 degrees. Then we add a modal solution to increase its boiling point, resulting in 94 degrees. The second experiment was about determining the Van Hoff coefficient. First, we have to determine the boiling point of a modal solution known by the teacher that it was gave to us. Then, with the boiling point obtained, we determine the Van Hoff coefficient of the substance. The third experiment was about determining the modal constant of fusion. First, in a test tub, we put 4 milliliters of cyclohexane. Then we cooled it with ice and determined its fusion point. After that, we add 0.1 grams of alkaphor, shake them, and then determine its new fusion point. Then we repeat the last step until we complete an alkaphor mass of 0.5 grams. Then we determine the constant of fusion of the cyclohexane. Then, after having the grams of cyclohexane, the grams of alkaphor, and the molecular weight that we use, and the density weight, we did obtain the molality. After that, we obtained the solution known as Tc in degrees, and then the Tc of the solution. We have to multiply the I, Kc, M plus the Tc of the solution. Then we did a table and Excel, and then we did obtain a graph showing the different points of the colligative properties. Analysis of results. There are various properties of the solutions are reduced from the size of the particles that are dispersed. Colligative properties are those that depend on the concentration of the solute and not on the nature of its molecules. The relationship presented in the graph, delta T versus molarity, is necessary to be able to obtain the Kb, and based on this, to be able to verify the results experimentally by evaluating the constants obtained throughout the practice. And according to these results, it was possible to verify that the experimental data have a degree of error compared to the calculations obtained and coincides in books. General conclusions. The calculation of Kf are different in each substance, although they present similarities in their states of aggregation. They depend very much on their compounds and colligative properties. Kf and Kb are specific properties and can change with alterations in compounds or dissolutions. There are also variations in the melting and boiling point, and this depends on the atmospheric pressure of the place where the experiment is located.
In the practice, we learn to analyze and better understand colligative properties. From many times trying the same experience, within these sessions, we were able to calculate the boiling point of different substances. We observed that a technique used in the lab can be used in everyday life. In order to obtain a lower temperature, we observed that the lower the mass of substance X, the lower the melting point.
This workout recognizes the importance of colligative properties of chemical solutions, and understand this process is what it happens.
This practice helped me to have patience in the process of freezing the mixtures and then measure the temperature so we can prove that adding a different quantity of solute in the cyclohexane can reduce its fusion point.